Hey guys, today we're on 3.09, the quadratic formula. You've seen it before, you've worked with it, but we're going to work with it even more today so you become even more of an expert. This also means we're close to the end of the unit, just a heads up there. Our goals for the day are to solve quadratic equations by using the quadratic formula, of course. Solving quadratic equations that look like this, basically what that means is we're using the square root property where because only the variable x is squared, and solve quadratic equations with real coefficients that have complex solutions. So yes, there will be some imaginary numbers. Let's get it started. This is a review from Algebra 1 because you're no stranger to the quadratic formula, but this is a reminder that you can solve any quadratic equation using the quadratic formula. That's the reason many people prefer this method, but you have to be very careful because there's a lot going on, okay? So let's go through the steps very carefully of solving using the quadratic formula. The first thing, the very first thing you always need to do is get it in standard form if it's not already. Sometimes it is, sometimes it's not. Remember, the standard form looks like this, where you have your full quadratic polynomial on the left, and it is set equal to 0. Okay, if there's other numbers or terms over here other than 0 or on the other side, you need to get them all on the same side. Okay, so if we look at this equation, the question is it in standard form? Well, hopefully you can see that no, it's not. We get it in standard form by using inverse operations to get everything on one side. Now, it doesn't matter which side the equal sign is on. The commutative property of equality says you can flip those around. Just like if you could say x equals 2, you could say 2 equals x. Those mean the same thing. Just as an example to remind ourselves. So that's step 1. Step 2 is identify A, B, and C very carefully. They are the coefficients. Take the numbers with the signs. Leave everything else. So x squared and x, we don't need it. So A is 2, B is 6, and C is 10. So if you didn't notice this wasn't in standard form, and you just said, okay, A is 2, B is 6, and C is -10, well, C would be incorrect, and you are already setting yourself up to get the problem wrong. The rest of the work wouldn't be quite correct. Now that we have our A, B, and C values, we want to substitute them into the quadratic formula that we see right here very carefully. Okay, so let's do it. I'm going to start by writing what's already there. Okay. Now, any place I'm going to substitute, I'm going to use parentheses. That's going to really help us keep everything accurate and avoid making mistakes. And now we substitute, okay? We have B here and here. We have A here and here, and C there. Double check. Double check. There's a lot going on. This is the setup. Let's see. Negative. B plus or minus. B. B should be 6. That's right. Okay. A times C. 2 times 2. We got it. Let's move on. Do what's easiest first. -1 times 6. 2 times 2. Now we need to simplify this radicand, right? So we're not taking the square root of all this yet. We're multiplying this all together to see what it gives us. Now we're going to get a negative number. Let's see what it is. 36 times 8. Let's see. We have 36. Let's just do it one step at a time. We have 36. And then we have negative 4 times 2. So negative 8 times 10, negative 80. So we're going to get a negative number in there. Square root of negative, let's see, 44. What this shows us is we're going to get imaginary numbers because we have the square root of a negative number. So what are those factors of negative 44? Let's see. Well, you should right away always factor out negative 1. You could use a factor tree on the side, but most of us can quickly see that 4 times 11 would give us 44. And 4 is a perfect square, 11's prime. So it's looking good. Okay, what else? Let's see. So square root of negative, sorry, let's start with the 4. Square root of 4 is 2. Square root of negative 1 is I. And then we have square root of 11 trapped forever. Okay, we're close. And one of the most common mistakes is people get to this point and they go, I'm done. But it's not fully simplified unless all of the constants and coefficients are divided by the GCF. So the coefficient here is 2. Constant here is 4. Constant there is negative 6. So 2 goes in here once, twice, and 3 times. Now let's write out our simplified answer. Negative 3 plus or minus I square root 11 over 2. There it is. Now, don't forget what the plus or minus means. That means you have 2 different answers here. Okay? So to help us, in case you see 2 different answer choices on your quiz or a test or something like that, let's show how you write these separated. Now, you could write this as negative 3 plus I squared 11 over 2. And then you could do the same thing just with a minus sign. That's how you could show your 2 answers. Or you could also show it as the real part first and imaginary second. Negative 3 over 2 plus or minus. Now, be very careful here. Negative 3 is divided by 2, but isn't I squared 11 also being divided by 2? It is. So the second part of this would be, sorry, I put plus and minus, should just be plus I square root 11 over 2. And then the second answer, real part first, minus imaginary part second. So this is another way to write your answers, just in case. And there will be a question like this on today's quiz. So good thing we practiced that. Now, it is time to practice some more. So we want to solve by completing the square. Actually, I skipped one. Here we go. Solve using the square root property. This doesn't take too many steps. We've done it before. What do you think you do first? For the rest of these problems, I suggest pausing the video, try it, and then watching what we do. Now, what's happening to x? 6 is trying to multiply with it, and it's being squared. So we know that things are touching, they're multiplying. Inverse of that is division. Inverse of squaring is square root. If I square root both sides, don't forget the plus and minus, just like peanut butter and jelly. It's a package deal, okay? But 6 isn't a perfect square, is it? X squared is, but 6 isn't. So that's not going to be the easiest way to do this. Easiest way, I always tell you, start doing the easiest thing first. If you divide both sides by 6, I believe this is 36. Let me double check. Yes, it is. Now we take the square root because we want x by itself, and don't forget the plus and minus. So you get x is plus and minus 6. Again, if you're writing that as two answers, it's x equals positive 6 and negative 6. Again, two different ways to write your answers. Okay, not too much work on that one. Let's solve by completing the square. There are written out steps in the top right corner that looks like a lot. So if it helps you, great. If it doesn't, leave it alone and just follow along after you practice this. So completing the square, if you remember, means you need to first move the constant to the other side if it's not already. Okay. Now, one other thing I'd like to mention here that's very important is the leading coefficient must be 1 when completing the square. Okay. So just a side note, think about maybe if this was leading coefficient of 4, right? How would you solve that? Well, you need to divide everything by that coefficient, right? So you need this to be 1. Very important. That's why it's the first step. Now, we need to use this handy dandy little formula to find the magical missing term. B in this case, well, we can see that's positive 10. And divide and then square, so you get 25. And why is it magical? Because it completes the square. In other words, what that means is now what we have on the left side of the equal sign is a perfect square trinomial. And notice we added 25 to both sides. Okay? So let's simplify. On the left side, you could use the x method and see what you get. Clearly, you can see 5 times 5 is 25. 5 plus 5 is 10. So we're going to get x plus 5 times x plus 5. What do we get on the right? 34. Now, x plus 5 times itself, a smart way to figure this out would be to square that so that we can then take the square root of both sides. So let's do it. Square root, plus and minus. Now we have x plus 5 equals plus and minus square root of 34. Now you could see what 34 factors out to, or subtract 5 to both sides. For now, I'm just going to subtract 5 on both sides. Okay, so we get this, and now let's see what 34 factors out to. What do you think? Factors? 4, 2, 6? Well, not 6. Let's try 2. Let's just do 2. So 17 times 2. Well, those are both prime, aren't they? So that is as simple as it can get. I'm not going to write out the answer in the two separate cases. This time we'll just leave it as is. Okay? Sorry, 1 second. Just moving some things around. All right. So hopefully you got that one right. If not, that's okay. Just practice. We're going to work on another problem here where we're going to factor by grouping or the quadratic formula. Take your pick. Which way do you prefer? I'm going to use factor by grouping because we haven't done that today. How do we factor by grouping? Well, once again, we need everything on the same side of the equation. So let's do it. Get that quadratic all set up. Okay. Now, let's factor by grouping. Remember, you need to use the x method to break up that middle term, right? So let's see. We get a times c and b. Interesting, very interesting, because that b value is so small. So let's take factors of -24 and see what we can get. Because this number is so small, it's going to add to a small number. We want numbers that are close to each other. So maybe 8 times 3. Could we get it closer though? What about 6 and 4? Yeah, there's a difference of 2. That should be our missing pieces of the puzzle. And you'll find that if you put 6 here and -4, 6 plus -4 is the same as 6 minus 4. So that does give us 2. All right. We're on our way. So let's go ahead now and break up that middle term to be 6x minus 4x minus 3, which this would equal 2x, right? You might be thinking that's a weird way to break it up, but that's why the x method is so useful in factoring by grouping, because now we can find the GCF of these two and these two to work it out the rest of the way. Now, can you find the GCFs? Here you should get 2x. What would that multiply to give you? 8x squared plus 6. 2 times 4 is 8. X times x is x squared. 2x times 3 is 6x. So you do want the same thing in parentheses. So I'm just going to go ahead and write that, set it equal to 0 again. Notice here, both the signs are just negative. So just put a negative. And we know there's no such thing as negative nothing. So it's actually a -1. So we group together 2x minus 1 times 4x plus 3. How do we solve from here? Do we remember? Zero product property, right? Set each factor equal to 0. And solve for x, and then we'll have our answers. 2x is 1, divide, divide. So x is 1/2. That's one of our answers. What about the other? Looks like we're going to get a negative fraction. X is also -3/4. And don't forget, the highest power of the polynomial tells you how many answers. X squared, 2 means 2 answers. Let's do one last problem together today. This is the exit tickets. Solve the equation. It's up to you to figure out what method you want to use to solve this. What methods will work? You have a quadratic leading coefficient is greater than 1. Okay. Dividing everything by 3, that's just going to make things messy, right? Lots of fractions. Can't just jump to the x method because leading coefficient is not 1. So personally, I'm going to use the quadratic formula. So is it in standard form? Yes, it is. Beautiful. So A, B, C. Well, I was going to draw arrows, but I'll just write them in. 3, -2, and 2. So let's get it all set up very carefully. negative b plus or minus square root of b squared minus 4ac all over 2a. Now let's keep going. Here we go. Negative times negative. 2 times 3 plus or minus. Now, what do you get? Negative 2 squared, 4. What do you get with the rest? Negative 24. Okay, we need to continue to simplify that radicand. So we're going to get negative 20. Again, imaginary numbers are here, and we got to work with them. So here we go. 2 plus or minus square root of what? Negative 1. You could factor out 20 on the side if you don't see what they are, but 4 times 5 will give us what we need. So we get square root of 4 is 2, square root of negative 1 is I, 2I. Familiar, right? We had that same thing before. And we have common coefficients, don't we? The constants and coefficient are all 2, so 2 goes into all of those one time, meaning your final answer will be 1 plus or minus 1i square root 5 over 1. Or we don't even need to show that it's over 1, right? So this is our answer. And where is that answer choice? Did we make a mistake here somewhere? Oh, I did. I don't know why I just turned the denominator into a 2. So let's change that to a 6. Change it to a 6. Here we go. So 2 goes into 6 3 times. So we're actually going to get this same thing we had, but over 3. So answer is D. That's it, my friends. Practice, practice. Until next time.